All right, so this time we are going to determine more key characteristics of your quadratic function graphs. And we have one in here that is open upwards. And this time we are also going to determine the x-intercept or intercepts, the y-intercept, domain range, as well as end behaviors. All right, so let's review a little bit on let me get this thing here. Let's review on your x-intercept. So basically, x-intercepts are points of intersection between your graph. Okay, so between the graph and x-axis, intersection points. All right. So really, we just have to look at your x-axis, which is your horizontal axis, and your graph, and locate where they intersected. All right, so this one would be one intersection point, and this is also another intersection point. So to determine the x-intercept, this is a point. So therefore, we need to name the coordinates of these points. So this one here is negative 1, 2, so that's negative 1, 0 because it's on the x-axis. So negative 2, comma 0. And the other one, this point right here is 1, 2, 3, 4. So that will be 4, comma 0. So these are the names of these 2 points right here. And they are what you call your x-intercepts. All right, so for y-intercept, this is the graph and y-axis. Oops, not x, but y-axis intersection point. Okay, so there is only one y intercept. Unlike x intercept, it could be more than it could be more than two, it could be one, it could be zero, it could be any number actually. Okay, depending on your function. All right, but for quadratic function, it could either be two or none. All right, so for this instance, we have two. Now for y-intercept again, so this is your graph and it intersected the y-axis at this point right here. So we will just have to estimate that point. Okay, so the x coordinate is 0 because it's on the y-axis. And let's count negative 1, 2, 3, 4, 5, 4.5. So that's negative 4.5. All right, so that's negative 4.5 for your y-intercept. Now again, for domain and range, as well as end behavior, it will probably be helpful for you to break down the component of each end. Okay, so let's concentrate on this end. As you can see, this end has a tendency to go all the way to the left, okay, and all the way up. Okay, the left motion is basically your x component, so that goes to the left all the way to negative infinity, and this one goes positive infinity going up. Okay, so up, okay, up and right, these are positive infinity, and then let's put down and left, these are negative infinity. Okay, so this is left, that's up. Okay, now on the other end, this one goes all the way to the right, so therefore that's positive infinity, and all the way up, that's positive infinity. And of course, it's also important for us to locate the lowest point, which is your vertex right here. Okay, that vertex is 1. It's 1, comma 1, 2, 3, 4, 5, negative 5. 1 comma negative 5. Why do I have to locate the vertex? Because remember, the vertex is either the lowest point or the highest point in your graph. And in this case, this is the lowest point. This will be useful when you look for your range. The range is the lowest to the highest value of your y. Alright, so let's start with our domain first. Domain, these two arrows that are horizontally oriented. So you have negative infinity to all the way to the left and positive infinity all the way to the right. Basically, it covers all the real numbers. So we'll just write here from negative infinity all the way to positive infinity. All right. Now for range, so let's go back to domain. Domain really tells you the leftmost number to the rightmost number and everything in between those two numbers. Okay. Now, for your range, this is the lowest point to the highest point. So that's why we needed to locate the vertex, because the vertex basically tells you the lowest point in this graph. And as the y component of that lowest point is negative 5. Okay, so we will start with negative 5. And the highest point, of course, is these two arrows right here are both positive infinity. So we'll just put one positive infinity. Okay, now let's go to end behavior. End behavior tells you the behavior of your ends of the graph. So we have two ends, this left end right here and this right end on the other side. So for now, let's concentrate on this left end. This is your x, that's your y. So this one is telling you that as x approaches negative infinity, which is this arrow means approaches, as x approaches negative infinity, its component y approaches positive infinity. Okay, or in other words, as this end goes to the left, it also goes up. Okay, now on the other end, this end right here that I'll put in a box. Okay, this end right here, this is your x. As x approaches positive infinity, y also approaches positive infinity. So we'll write that here. As x approaches positive infinity, y approaches positive infinity as well. Okay, so we may need to practice more on the breaking down of this, because this will actually help you on your domain, range, and end behavior. Okay, so on page one of your packet, this is our learning target. Okay, so given graphs of quadratic function, I can determine the following. So these are some of your key characteristics: domain, range, and behavior, x and y intercepts. So most of these questions here are inside this box, and on this little box here, these are reviews of last week. So we will start with the review first. Okay, so let's determine the vertex of this graph, which is right here. This is the lowest point. So that is positive 1, negative 2. So we'll write that here. That's 1, negative 2. Axis of symmetry. This is our axis of symmetry. I'm not going to draw because I don't want to mess it up. But basically, your axis of symmetry is whatever your x component of the vertex. But we just have to write x equals positive 1. Without x, I will not consider it correct, because axis means a line, and if you do not put an x, it's just a number. All right, there's a question here. Is a, which is a coefficient of your x squared, negative or a positive number? Okay, since this one opens up, since that's up, then therefore that is positive. If it opens down, that's negative. So therefore this one is positive number. Okay. Is the vertex a maximum or a minimum? So as you can see, the vertex is the lowest point. So therefore, that is a minimum. Okay, so now let's go to our x-intercepts and y-intercepts. So let's locate the x-intercept. So this is the pink line here is your graph, and this is your x-axis. So this is the point of intersection. And on the other side, this is the other point of intersection. All right, so let's locate this. So this is 0, negative 1, but this is halfway. So this is 0, negative 1 half. So therefore your x is negative 0.5, which is 1 half, comma 0. All right, and the other one, this. So this is 0, 1, 2, 2.5. So that will be 2.5, comma 0. I'm hoping that by now you'd realize that when you're looking for x-intercepts, your y component or y coordinate is always 0, because all y coordinate along the x-axis are really 0. Okay. Now for y-intercept, okay, y-intercept is the intersection of your y-axis and the graph, which is this. So let's just make that one negative 1, right? So your x component for that is 0, and your y component is negative 1. So we have the x and y intercepts. Now let's do the domain, range, and end behavior. So for these three, we needed to, well, we don't really need to, but I think it would help if you break down the end parts. Okay, so I'll break this one down, going to the right, which is positive infinity as it goes up. Okay, and this is also positive infinity. This one goes up, positive infinity, and go to the left, negative infinity. Okay, So therefore, these two horizontal lines are your domain. So let's put that here. Sorry for my dog. Negative infinity all the way to positive infinity. And your range is not positive infinity to positive infinity, okay? Because the range is from the lowest point to the highest point. Your highest point is positive infinity, but your lowest point is the vertex, which is, we know that the vertex is 1 comma negative 2. So therefore, the y component, range is for the y component. Your lowest point is negative 2. Start with negative 2 all the way to positive infinity, okay? Now, end behavior, we have two ends. So let's set this one up as x approaches. Okay, so this part right here, as x approaches negative infinity, y approaches positive infinity. Okay, so as x approaches negative infinity, your y approaches positive infinity. Okay, so this is for this end. Now, for this end, as x approaches positive, y also approaches positive. Okay, so I'll just write it here. As x approaches, this arrow here means approaches positive infinity, your y also approaches positive infinity. All right, so why don't you practice the rest of the pages? I think it's pages, let me see that. We may have 2 pages for this. All right, yep, pages 1 and 2, and let me know if you have any question.